All right, so this is 9.2 day 1, and there is a day 2 of this, which is a continuation on new figures after they were done with these ones. But very important thing to say right now. The whole goal by the time we're done with these notes is for you to be able to look at the given equation right here. Well, not the one, but look at this equation, know what it is, and snap, graph it. The whole goal is to look at this, know what it is, and graph it. Know what this is and graph it, okay? It isn't for you to make a table. The goal isn't for you to make a table. The goal isn't for you to do what we are doing to see what they look like. We are going to discover what they look like, but once we know what they look like, our goal is to snap. That's what it looks like, graph it, okay? I want you to keep that in mind. You are going to need Desmos for this at some point, so might as well just open it now so that I can use it later. All right, and then I'll close out of it and go back to today's notes. All right, so the first two, we're going to use a table to help us see what it looks like, but then we're never going to use a table again, okay? All right, so the equation is r equals 3. So I have a table for theta and r, and notice that r is 3. So no matter what, r is 3. I'm going to have 3 for r, no matter what theta value I plug in, okay? What theta values I can plug in? Anything from this graph paper. So I can plug in pi over 6, and I can plug in pi over 4, and I can plug in pi over 3, and I can plug in pi over 2, and so on and so forth. I'm going to get 3 no matter what. So now let's graph these points. We learned how to graph points yesterday. So it's 3 comma pi over 6. So I'm going to go to pi over 6, and then I'm going to go out 3. 1, 2, 3, and make a point there. Do the same thing at pi over 4 and pi over 3 and pi over 2 and at every single angle for around and around and around and around forever. So if you notice, if I keep doing that and I keep going around, I'm going to get a circle, which I have a very hard time making, but iPad help me. Thank you. Okay. I tried. Guys, there's my circle. Let me move it over a little bit. Ugh. Okay, stop it, OCD. All right, it's fine. All right, so that's what it looks like. So r equals 3 is that circle right there. If you look at what's special about this circle, where's the center? Okay. The center is the origin or the pole, right? 0, 0. The center is 0, 0. What's the radius of this circle? 1, 2, 3. The radius is 3. The radius is 3. The center is 0, 0. When you see r equals 3, okay, or r equals a number, let's actually fill in everything other than this. So what shape is it going to be? It's going to be a circle. When you see r equals and then a number, I'm going to use a for a number and put a as any number. It will always be graph of a circle, okay, with center 0, 0. You just learned that, right? Okay, and then whatever the radius is, that's a radius. Do you have to draw on this r equals 3 right here when you draw it? No, okay, but it's nice to have it, right? All right, let's convert it to rectangular form. We did this yesterday, and I want you to see the connection, okay? So I want to get rid of the r. I can't get rid of the r because there's nothing to replace r with. I can replace r squared, though. So if I square both sides, I know what 3 squared is. So I'm going to square both sides. R squared equals 3 squared. R squared I can replace with, what's r squared the same thing as? X squared plus y squared. 3 squared, 9. There, it's in rectangular form. So if you look, this is a circle with center 0, 0 and radius 3, okay? Just like this is. Do I want you to convert to know that? No, I want you r equals 3. Oh, that's a circle. Center 0, 0, radius 3. Okay, try this other one. Theta equals pi over 6. Once again, I'm filling in a table to discover what it looks like. So theta is always pi over 6. So pi over 6, 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 so on and so forth. I'm going to put dot, 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 because they're all pi over 6s. Then r can be any value. So just like we said theta could be any angle in the previous one before and I started picking angle, r can be any value. So it can be 0, 1, 2, what else is on here? 3, 4, 5. Or it can be -1, -2, -3, -4, -5. So I'll just do -2, -1, 0, 1, 2, dot, 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 whatever. Okay? All right, so let's do pi over 6 0, or 0 power over 6, power over 6, 1, 2, it could be 3, 4, 5, it could be 3.5, it could be 2.5, whatever. But then it could also be negative. So if you keep going, right, you see that what you end up getting is this sloped line right here that goes through pi over 6. So when you see theta equals, and then it's an angle, but we'll just put A for a number because it can be any angle. What shape is it? It's a line, okay? It will always be a graph of a line, and it's going to always be a graph of a line. I almost said always a sloped line, but if I gave you theta equals 0, then it's not sloped. It has no slope, right? If I gave you theta equals pi over 2, then it is a vertical line and it has no slope. So I'll just say it's a line. All right, next one I don't have a table for because it's easier just to convert these to see what they are, okay? All right, so remember converting means get rid of r and theta. So I need to get rid of this. R sine of theta is replaceable with what? What's r sine of theta the same thing as? Y. So this is y equals -1. That means y equals -1. We know how to graph that. It's a horizontal line going through -1. So let's graph that. I'm going to put a point that's down 1 from the origin to help me graph it. And then I'll draw a horizontal line to the best of my ability. Going through. That's y equals -1. Right? So r sine of theta. So what shape is this going to be? This is going to be a line once again. Okay? If you see r sine of theta equals a number, that's a line. Okay? Same idea here if we saw r cosine of theta. R cosine of theta is the same thing as x. So this is x equals 2. That means that's a vertical line at 2. So I'm going to go 2 to the right of the origin, make a little dot there so I'm going through the right value, and then draw a vertical line going through that. So this, don't forget to put arrows on the end, right? So if you see r cosine of theta equals a number, that will also be a line. So both of those are lines. Okay, and we did A. We did it up here, though, just so we all realize that. Okay, now we're on number 5, and we're back to a table. So we're going to use a table to discover what shape this is, okay? All right, so I need to plug in theta measures because I need to plug in theta measures to get r values, right? Once I plug in theta, I know what r is. So I'm going to think about doing this here. So I'm going to start by trying to plug in 0. I'm not going to just fill this in here. Now, will you ever have to do this again on your own? No. Sorry, that's my boot making noise. All right, so I want to know what 4 times the cosine of theta is, where I picked theta as 0. So I need to know what the cosine at 0 is. This is the ordered pair 1, 0. Cosine is the x value. So it is 1. 4 times 1 is 4. So I have the point 0, 1. Sorry, 0, 4. All right, so the next one I want to move to is I'm going to see if pi over 6 is helpful. Now remember, I'm using the cosine. This is root 3 over 2, comma 1/2. If I do 4 times root 3 over 2, that's 2 root 3, which, what the heck, how am I going to graph that, right? So I'm going to skip over that one. Pi over 4 is root 2 over 2 for cosine. I'm going to get another decimal. I'm going to skip over it. I'm not sure what it is. But when I get to pi over 3, that's 1/2 root 3 over 2. Cosine's 1/2, so that I can do 4 times 1/2 in my head. So I'm going to start by, or not start by, but I'm going to do pi over 3 next. And that is 4 times 1/2, which is 2. See that? So if you notice, I'm going to do only my quadrantals and my pi over 3 angles because those are the only ones I can do in my head. I can use my calculator for the other ones, but I'm not going to. So this is 0, 1. At 2 pi over 3, that's -1/2 root 3 over 2. At pi, that's -0, 1. At 4 pi over 3, that's -1/2 negative root 3 over 2. At 3 pi over 2, that's 0, -1. And then at 5 pi over 3, this is -1/2 negative root 3 over 2. So I'm using this cosine value next, right? So I'm going to do pi over 2. And that is 4 times 0, which is 0. Then at 2 pi over 3, I'm going to do 4 times cosine, which is -1/2. And that gives me -2. All right, then I'm going to go to pi. It's 4 times the cosine, which is -1. So it's -4. And then I'll go to 4 pi over 3. 4 times the cosine, which is -1/2. So that's -2. 3 pi over 2. 4 times the cosine, which is 0. So 4, 0, which is 0. And then 5 pi over 3. 4 times 1/2, which is 2. Okay, so if you felt like that was a little fast, will you ever have to do it again? No, we're never going to use a table again. I want you to be able to look at this and tell me what it is in the future. But let's see what it is. Let's graph some of these points here. So I have 0, 4. So at 0 radians, I'm going to go out 4. 1, 2, 3, 4. Right there. 0, 4. All right, so at pi over 3, I'm going to go out 2. 1, 2. At pi over 2, I'm going to go out 0, so that's the origin. At 2 pi over 3, I'm going to go out -2. So 2 pi over 3, instead of going in this direction, I'm going in this direction, right? Okay, so I'm going to erase that because I'm going to go 1, 2, and I'm right there. So notice that's the same thing as 5 pi over 3, comma 2, and I have 5 pi over 3, comma 2 right here. So I already knew that. All right, then I have pi -4, so I'm not going this direction, I'm going this direction, and I'm like, oh, I already have a point there. So what you're going to see is now those points just repeat over and over again. So I have this point, then this point. Oops, I erased, and I don't want to do that. I'll just change the color so you can see what I'm pointing to. Actually, I'll highlight. I have this point, then 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 this point. But it doesn't form this shape. It doesn't form a kite, okay? I skipped over a bunch of angles to plug in. So what you have to realize is that this is forming a circle, okay? Now, if you don't realize that, we'll look at it in our calculator in just a second to get a better idea, okay? It's forming a circle. If you connect those, you can make a circle, okay? So let's write down that it's a circle. Convert it to rectangular form. Before I convert it to rectangular form, let's see what we notice about it. Here's the center. Our center is 2, 0, and here's our radius, it's 2. So let's write that down. The center is 2, 0, and the radius is 2. Okay, the center is 2, 0, and the radius is 2. All right, let's convert it to rectangular form. So I need to get rid of this r, so that means I'm going to have to square it. But should I square this side? No, because then I get something I don't even know what that is. Instead, I'm going to multiply by r, multiply by r. So I get r squared equals 4 r cosine theta. I'm going to erase those up there. All right, now I'm going to replace. What can I replace r squared with? X squared plus y squared equals 4. What can I replace r cosine of theta with? X. And now it's in rectangular form. Find the center and the radius. We already did that. Center. Actually, what am I doing here? The center is 2, 0, and the radius is 2. Okay? A polar equation in the form r equals a number, cosine of theta, is always going to be a graph of a circle. Okay, so I have to be able to look at this and know it's a circle, which is fine. Like, okay, r equals a number, cosine theta. It's a circle. I got it. Like it says it right here. But I also need to know that the center is 2, 0, and the radius is 2. So how am I going to get that? Just by looking at one example, it might not be jumping in my head. So we're going to look at 3 more examples. Instead of doing them by hand, we are going to use our calculator for help, okay? Now, we could use a graphing calculator or we can use Desmos. I'm going to use Desmos because it's just easier to type in. It's easier for us to work with it. So I'm going to use Desmos to do it, okay? All right. So, actually, you know what? Yeah, I'm going to use Desmos. I was going to use both for a second. Oops, I wanted to open it side by side. Maybe on the other one I'll show you. And day 2, I'll show you how to type it in your calculator if you want to. That's what I'll do. Okay, so let's type in this first one right here to see what it looks like. So I'm going to click on where it says 1, and I'm going to do r equals. So there is no r on my screen right now, so I have to hit ABC. Then I can choose r, And then I can go back to 1, 2, 3 to get the equal sign. And then I need a -4, so -4, and then I need cosine of theta, okay? So notice if I put r equals -4, it gives me a circle. Like we knew that, center 0, 0, radius 4. But it's cosine theta, right? So click on the functions button, choose cosine, and now I need theta. Theta is not on my screen right now, but if you hit ABC, it's right below P or to the right of L. It's right there. And then you can see you get a circle right there. All right, so that circle I want to draw now, okay? But if you look, this is rectangular paper. Might be a good idea to change this to polar paper, right? If I want it to look like this, I'm tapping and you can't see me, but that polar paper over there. So if you hit that wrench in the upper right-hand corner, notice right below the word grid, it has vertical and horizontal lines, or it has this polar paper. If you click on polar paper and then click back on there, you can see it related closer to the polar paper here, okay? So what you can see is that it touches 0, 0, right? And then if you look, you can count out 1, 2, 3, 4. The diameter is 4, and you go to the left, 1, 2, 3, 4. 1, 2, 3, 4, right there. And then I can just make my circle from there. Okay? So I want 2 pieces of information from this also. What's the center and what's the radius? I made a typo. I only put the radius. I want the center too. So if you look right here, if you look right here, here's the center and here's the radius. So the center is negative, I'll put a C here for center, is -2, 0, and the radius is 2. These, once again, are going to be circles. All right, let's try the next one, because maybe I'm like, I still don't know what the pattern is. So I'm going to change this. I'm going to change this to a 2, and then I'm going to change cosine to sine. Functions, sine. You could have just deleted it and retyped it, but hey, I wanted to do it like that. All right, if you look at this circle, it touches 0, 0, just like the other one did. And then if you go up 2, you'll have your circle right here. Okay, so there's my circle. If you look here, there's my center right there, which is 0, 1. And my radius is 1. All right, do we need Desmos for the next one? I don't think we do. We can always double check it in there, but I don't think we do. Okay, so let's see what's happening here. This radius is 2. If you look at this number, it's 4. This radius is 1. If you look at it, this is 2. So what we can think about it is saying, okay, well, what's this radius? This radius, if that's a 6, this radius is going to be a 3. Okay? But what about the location? Because if you look, the circle has moved. Here, it was on the positive x-axis. Here it was on the negative x-axis. Here it was on the positive y-axis. What is telling us that? If you look here, this is cosine, and this is a positive number, positive x. This is cosine and a negative number, negative x. This is sine and a positive number, positive y. This is sine and a negative number. This is going to be on the negative y-axis with a radius of 3. So let's go ahead and graph that. We're going to go, it's going to touch 0, 0. It's going to be on the negative y-axis with a radius of 3, so that means the diameter is 6. I'm going to go down 6. 1, 2, 3, 4, 5. I fell off my graph paper, but no big deal. 6. I could also draw my center if I want right now, and then go ahead and make your circle. And that's what it looks like. So my center is 0, -3. So you can tell what these look like without using your graphing calculator, okay? You can tell what axis they're on, how big their diameter is, therefore how big their radius is, and also where the center is because you know what axis it's on. So if you see an equation in the form r equals, and it's a number cosine of theta, or r equals a number sine of theta, then these will always be graphs of circles. All right, I'm going to move Desmos out of the way for a moment because I'm going to recap, because I'm going to have you pause the video and try number 9 on your own, okay? So if you see r equals a number, circle. If you see theta equals an angle, line. If you see r sine of theta equals a number, r cosine of theta equals a number, line. If you see r equals 4, or sorry, not 4, a number cosine of theta, or r equals a number sine of theta, it's a circle. Go ahead and do pause the video, try number 9. See if you can identify all of these 8, and then I'm going to ask you follow-up questions on 3 of them. Okay, let's see how you did. This is theta equals, so it's a line. Theta equals, so it's a line. R equals a number, it's a circle. R sine of theta, if you can't remember if it's a circle or a line, say what is r sine of theta the same thing as. It's the same thing as y. Y equals 1 is a line. R cosine is the same thing as x. X equals -5 is a line. All right, r equals 5 sine of theta. R equals a number sine of theta is a circle. And last one, there's this +4 right here. So I was like, okay, wait, I need to get rid of that. So I'm going to -4 from both sides. I have r cosine of theta equals -4. R cosine of theta is the same thing as x. X equals -4 is a line. All right, here's your follow-up questions. On the circle, ooh, I skipped one. This is r equals 2 cosine of theta. That's a circle. All right, here's the follow-up question. There are 3 circles. I want to know what the center and the radius of the circle is. Okay, so let's go to this one right here. What's the center and the radius of the circle? The radius is 4. Okay, the radius is 4. What's the center? 0, 0. If it's r equals a number, the center is 0, 0. All right, let's do E next. I need the center and I need the radius. The center is not 0, 0. So since the center is not 0, 0, I do a quick sketch. And I say, okay, which axis is it on? Positive x. So then I draw a circle on the positive x-axis. And then I say, okay, well, I know this is 2, so my radius is 1. And that means this point right here is to the right 1, so 1, and then up nothing, 0. Let's do G really quickly. I'll need a quick sketch to answer the question. Okay, it's on the positive y-axis, so I do a quick sketch of a circle. I try to do a quick sketch of a circle. There we go. I know this whole thing right here, the diameter is 5. The center's right here. So the radius, that means, is half of 5, which is 2.5. And the center is over 0 up 2.5. Okay, so you can graph these snap in a second by looking at the equation now. All right, the last one that we're going to talk about in this set of notes is our cardioids. Cardioids is another word for heart. Okay, if you look at a cardioid, these are the 4 forms that it can be in. R equals a times the quantity of 1 plus cosine. R equals a times the quantity of 1 plus sine, so on and so forth. But a is always going to be distributed. So what you're going to notice here is that these all have the same coefficients. This is a 1 and a 1, a 1 and a 1. This is a 2 and a 2, a 2 and a 2. So that's how I know it's a cardioid. Okay. We're going to see ones that are like 1 and 3 tomorrow, and it's not a cardioid. So I want you to realize that. Okay, let's put these, we're going to put these directly into Desmos to see what these look like. We're not going to make tables. We're just going to see what they look. Cardioid looks like, what axis it's on. That's what I want to know. What it looks like, what axis it's on. Okay, so let's open up Desmos here. All right, so I'm going to hit X on this right here because I don't need that one anymore. And I'm going to hit 1 minus, oh, sorry, no, I'm not. I'm going to hit R equals, so I need alpha R equals 1 minus, and then it's 1 sine of theta, but you can just hit sine of theta. So sine, where are you? Sine of theta. Okay, and I'm going to attempt to zoom in. I think I'm going to hate, maybe if I just hit the plus sign. Oh, yeah. Okay, good. All right, so I zoomed in so you can see it better. But that's what a cardioid looks like. It's heart-shaped. It's not perfect, but it has that indent that hearts have. So let's do a rough sketch of what this looks like. It definitely touches 0, 0, okay, and it's in that indent. And then you can see it goes down 2, but I'm just going to do a rough sketch of it. I'm not going to like make it perfect here. And oh, that is like the best cardioid I've ever drawn in my life. But what I want you to notice is that it's on the negative y-axis. Negative y-axis. Okay? That's what you need to know. It's on the negative y-axis. And this, I don't know what to call it, the convex point, the concave point. That's what it is, not convex. Concave point right there is at 0, 0. All right, let's try another one. So this one is r equals 1 plus. So I'm just going to tap there, go backwards, and hit plus instead. So notice it just moved to the y-axis, but that indent right there is still at 0, 0. Okay? Oh, here we go. Oh, my goodness. I'm going too slow. That's the problem. Perfect. Well, not perfect, but good enough. Okay? Now, do you have to make sure it touches this? No. I want to know. I'm okay with you just saying, okay, it's on the positive y-axis and it touches 0, 0. All right, next one. I'm going to do 2 plus 2 cosine, so I'm going to get rid of this. R equals 2 plus, oops, I hit minus. Oops, I hit backwards instead of that. 2 plus 2 cosine theta. So function cosine alpha theta. There we go. Now this is zoomed in a little too much, so I'll zoom out. All right, now we have a cardioid here. So once again, that indent there touches 0, 0. It's on the positive x-axis. So it's on the positive x-axis. This one's bigger. Do I have to make it perfect? No, I care about that it's on the positive x-axis, and you know that it's a cardioid. Okay? All right, let's do the other one without Desmos' help. We can confirm the answer when we need it, but it's on the negative x-axis, and it's a cardioid, and it's still going to touch 0, 0. So I'm going to draw it on the negative x-axis. Cardioid still touching 0, 0. Now I can change this to minus to make sure I did it right, just so we can see. Yep, I did. Okay? But the whole goal is to be able to look at this equation and know it's a cardioid. I know it's a cardioid because it's 2 plus 2 or 2 minus 2, and these two numbers are the same. And then a trig function right here, and it's r equals. Okay?